Good morning, children. In my previous class, we discussed about some electric motor, how it works, and before that, let me remind you about your activity. Activity 2, which I gave, it is a out of syllabus, that is deleted from the portion. So please, children, do once again activity 2, that is a page number 247. Page number 247, Principles of Metallurgy, Activity 2. Heading is Activity 2. And FA3 starts from March 1st. First on the first language, second language, third on March 3rd, English, March 4th, maybe mathematics, 5th is your physical science and biological science. The portion for the FA3 slip test physics portion is Principles of Metallurgy. Principles of Metallurgy. So already I gave the notes. Just your duty to learn. And those who are not coming to school, please children, whatever I am saying in a video, follow properly and do the revision. Last week I asked you to read as is basis and solves. Read and write all the answers without seeing and check yourself. Okay? What is the third FA3 portion? Principles of Metallurgy. It starts from March 1st month. Okay? Now comes to the electromagnetism. In this lesson, we are going to find the relation between electricity and magnetism. How electricity and electric field produces magnetic field, and how magnetic field produces the electric field. In electric motor, we can understand that electric field, it produces magnetic field. Already magnets are under the influence of a magnetic field. So these two magnetic fields make our coil to attract and repel. It makes a coil to move. This is the principle involved in electric motor. And what is a generator? Where mechanical energy is converted into electrical energy. And Faraday, when he observed that a copper coil, two ends of a copper coil is connected to the galvanometer. What is galvanometer? It is a device used to check the presence of a current. So we will have the reading in the galvanometer. If a current is produced, generated, it shows a deflection. So when copper wire is connected to the galvanometer and you took a bar magnet, just bringing the bar magnet near to the coil and moving away from the coil, he observed that there is a slight deflection in the magnetic galvanometer. It means electric field is developed around that. By changing the magnetic flux, if an induced current is produced, and that is said to be a Faraday's law. And what is the Lenz's law? What will be the direction of that induced current, artificial current, without batteries, without thermal or electrical power? Just by changing the magnetic flux, they produce the current. It is said to be a induced EMF or induced current. And what will be the direction of that induced current? It is given by a Lenz. Lenz is a scientist, and he described that induced current direction always it opposite to the magnetic flux, change in a magnetic flux. If a magnetic flux are moving inwards, the induced current produces in a outward direction. And we discussed about that around the electric field it develops a magnetic field, and around the magnetic field it develops the electric field. Based on this, a special branch is developed that is said to be electromagnetism. Here we discussed about a electric motor where it works on the principle of a electrical energy converted into mechanical energy, and generators are the devices which converts mechanical energy into electrical energy. And we have two types of generators, AC generator and DC, alternate currents and direct currents. There also we will use a coil and a magnet. Due to change in the magnetic flux, a induced EMF is produced. EMF, electromotive force, is produced. And electromotive force or induced current is produced, and this is said to be a AC currents. And how we will current AC generators into a DC and DC into a AC? By just adding the slip rings. This is the principle involved in that. And we discussed about a magnetic lines, magnetic field, magnetic flux density, Tesla is the unit for that, and Weber is also unit for that. What happens when a straight carrying wire, current wire is held in your right hand? Always thumb will show the direction of the current and remaining fingers will show the magnetic field. That can be explained by right hand thumb rule. It can be explained by right hand thumb rule. And what is a solenoid? A long coil, when it is wounded in a or fixed in a special packed helix, such arrangement is said to be a solenoid. When a current passes through a solenoid, how it behaves? It behaves like a bar magnet. Coming from the north, and all the magnetic lines enters into the south. So here in these two we discussed about a magnetic field, electric field, and magnetic flux density, electric motor, generator. The principle behind this also we discussed. So your FA starts from, this is the main for the Faraday law. What he took a wooden base on the wooden cylinder or wooden base, fix a soft cylindrical iron cylinder on that, and would a copper wire, two ends of copper wire given connection to the battery. Just insert a metal rod to that whose diameter is more. As soon as you place the connection past the current, the metal rod, the ring, it leviates. This shows that around the electric field it produces a magnetic field also. Magnetic field and electric field, how they will travel. So here this is the principle used in a Lenz law. I said no, just by Faraday law. This is a galvanometer and a coil. Two ends of coil are connected to the battery or a galvanometer. In his hand, what is there? A bar magnet. By changing the bar magnet flux, how will change the magnetic flux? Just bringing close to the magnet and moving away from the magnet. When we bring the close to the magnetic lines are more. When moving away from the magnetic lines are less. So due to change in the magnetic flux, a induced current is produced, and that is said to be a Faraday's law. Always Faraday's law in Lenz law determines the direction of the current. Always it is opposite to the magnetic flux. And this is the principle involved in a generators. Applications of Faraday's laws in our security checkups in shopping malls, and how they will use this Faraday law. It is nothing but induced current. If you hold any metal object and it passes through that, it produces a light and it triggers the alarm. And in tape recorders, when you listen to songs, record voice works on the principle of electromagnetic induction. The piece of a plastic tape coated with a oxide and magnetic more in the same path, and it is used in induction stoves. Electromagnetic induction, this principle is used in electric stoves also. You can see here a direct current and alternate current. In this, how we will use a rectangular coil, and it is under the influence of a strong magnets, and the coil is connected to a load resistance. To connect that, in between they arrange the slip rings also. This is the arrangement of a AC. And what changes we need to make an AC generator to be converted into DC? Two of slip rings are connected to the ends of the coil as shown in the figure, and this generator, now AC generator, works as a DC generator to produce DC current. So children, it works on the principle of a DC currents, and for every half rotation the coil directions will be the reverse. It falls to 0 to maximum and maximum. By seeing the graph also you can understand. Initially it starts with a 0 and reach to the peak, that is a maximum. Again slow downs to the 0. When it comes to the off rotation, it comes to 0. Again slowly it picks up and rises up to the peak. Again falls. 0 to maximum, maximum to 0, 0 to maximum. This procedure continues for every half rotations, and this is the principle behind the working of a generator. Generator works on the principle of converting mechanical energy into electrical energy. And how will be the direction of the current? Always it will be the outward, because magnetic flux will goes towards inside, so definitely it goes outwards. Who gave the direction of this current? Lenz. And Faraday's law is nothing but electromagnetic induction. Induced EMF, induced current is produced in a circuit due to change in a magnetic flux. The induced current is always directly proportional to rate of change of magnetic flux is known as Faraday's law. So with this we completed our lesson electromagnetism. A measure of strength of magnetic flux by taking account number of field lines is called magnetic flux. And magnetic flux is defined as a ratio of flux passing through a plane perpendicular to the field. Current carrying wire produces magnetic field. In electric motor, electric energy is converted into mechanical energy. The production of electric current due to relative motion between a coil and magnetic field is called electromagnetic induction. The induced EMF generated in a closed loop equal to the rate of change of magnetic flux. This is known as Faraday law, most important. Lenz law. Induced current up in the coil in such a direction that it opposes to the changes in the flux. When a conductor of length L moves perpendicular to the field B with a speed V, then the potential difference developed between the ends of the conductor is BLV. EMF is called motional EMF, that is a motivational EMF, electromotive phase. In generators, mechanical energy is converted into electrical energy. The lesson which we discuss is totally deleted from the portion. No need to write the notes and no need to read. So just what it is given in the electromagnetism I explained, Amma. What is your FA3 portion? FA3 portion is nothing but Principles of Metallurgy 11th lesson. And activity 2, once again you have to do, that is from the Principles of Metallurgy, page number 247, activity 2. Try to complete that activity and submit in the school. Before first, if you submit and collect your book back, so easy for you to write your slip test in a project book only. Okay? And complete the revision of acids, bases and salts, those who are not coming to school. Already I gave few answers for you to read. Today also Principles of Metallurgy revision started. First 5 answers from what we have learned. From the what improve your learning, not what we have learned. From the improve your learning, I gave first 5 answers from the Principles of Metallurgy as a part of FA3 revision. As a part of a FA3 revision. Try to complete that answers. Read daily 5 to 10 answers if you read. Within 3 days you can complete your revision. Okay ma, all the diagrams of Principles of Metallurgy are important, and activity corrosion is important, and roasting, concentration, purification, metallurgy, all these are important. Thank you children.